This one is October, November 2016 paper. Paper 4, first variant. We'll discuss organic chemistry questions. Petroleum is a mixture of hydrocarbons. It is separated into useful fractions by fractional distillation. This can be done using a fractionating column as shown. What happened to petroleum at point X before it entered the fractionating column? So what happened to petroleum before it entered to a fractionating column at point X? It turned into vapor, heated and turned into vapor. So answer here, at point X, it is heated and turned into vapors. Question number 3, part A2, 3A2. State two ways a fraction, how fraction O differ from fraction L. So which one you think will have higher, because as we go down, the melting point or the boiling point increases, the viscosity increases, means become thick, become darker in color, become denser as well. So O is denser, O will have high. So two ways in which fraction O differ from fraction L. So O will have higher boiling point. Greater boiling point, and it will be darker as well. Or you can also say it is viscous. Viscous means higher boiling and melting point, denser, that's correct. Darker as well, that's also correct. Any two you have to mention. So if you mention boiling point darker, or you mention boiling point and denser, so you will score the mark. But boiling, yeah, due to higher carbon number, or even you can mention a difference that it has greater carbon number. That's a reason as well to have high boiling point, greater number of bonds are there, high concentration of the carbon. In part B, most of the hydrocarbon obtained from petroleum are alkanes. The alkanes are homologous series of saturated hydrocarbon with a journal formula of CnH2n plus 2. Give two characteristics other than having a journal formula of a member of an homologous series. So what are the characteristics of homologous series? So each member differ by CH2 and they have same chemical properties. Physical properties gradually changes, same method of preparation, or same functional group. Yeah, similar chemical properties, physical properties gradually changes. Alkene with a molecular formula of C5 and H12 can exist as a number of structural isomers, means structures are different. In higher classes, in A levels, you will study even isomers have different types. It can be structural isomer, functional group isomer, chain isomer, optical isomer, stereo isomer. But here you are only studying the structural isomer, that two compounds have a same molecular formula and different structures. So this is alkane because C5 and H12 is an alkane. And I told you, if you want to draw an isomer, so what you will do, first draw the straight chain and then show the branch bond. Like example, because I have 5 carbon, so because I have 5 carbon and I have to draw 2 structure. So the first one I will draw a straight chain. Then put hydrogen. This will have 3 hydrogen. This will have 2 hydrogens, 2 hydrogen, 2 hydrogen and 3 hydrogen. And then for this one, I will just put a branch,
Sir,
but don't.
Sir,
Yes.
shouldn't we draw complete structures?
They did not mention show all the bonds. If they mention show all the bonds, then I have to show hydrogen bond as well. But if it is not mentioned in the question, then it is acceptable in this manner. If in the question they did not specify show all the bonds, so I can write like CH3. That's correct. But if it is written that show all the bond and I did not show all the bonds, I wrote CH3, then it's not correct. So you should check the question before drawing. Is it clear? What is the name of this compound? What is the name of this compound? 5 carbon and single bond proud.
Propane.
5 carbon.
Pentane.
Yeah, 5 means pent and throughout single bond ane. What is the name of this compound? You select the longest carbon chain. The numbering should start from nearest branch. What's the name of this compound?
Butane.
No. First we name the branch. What position of a branch? 2. Then how many carbon are there in the branch? 1 carbon. So we'll say meth. And because it is a branch, so YL. So it's 2 methyl. And there are 4 carbons, so it will be butane. So it's 2 methyl butane. Second is the position of a branch. Because there's 1 carbon in the branch, that's why it's meth. And due to branch, we'll have YL. And but, because 4 carbon but and single bond in, so it is 2 methyl butane. The alkane ethane has a structure as shown. When a mixture of ethane and chlorine is exposed to UV light, a substitution reaction occurs. Draw the structure of one organic product from this reaction. So what happened, like this is ethane, it is reacting with chlorine. So if you remember, substitution reaction means when atom or a group of atom replace the other group or atom, we call substitution. So what happened? One chlorine will take position of hydrogen and hydrogen will take position of a chlorine. It will form a chloroethane in which one of the hydrogen is replaced by chlorine. So this is the product which is formed. Here we have to draw organic product. So this is organic product because this is organic product and inorganic product is HCl. Organic product is chloromethane. So C2H5Cl plus HCl. That's correct. That's the equation. But because we have to draw the structure, so I drew the structure here. Isopropene is naturally occurring. Isoprene is a naturally occurring hydrocarbon. Explain how the name isoprene suggested that it contained carbon-carbon double bond. How you can say that it contains a carbon-carbon double bond? Yeah, because its name is having ene. So its name consists of ene shows there is a carbon-carbon double bond. That was empirical formula. That's why I skipped that part. Okay. This is about the polymerization. Nylon, tyrrolene, protein, all are polymers. What is meaning of a polymer? What's the definition of a polymer? How you define a polymer? So standard definition, reason to show your definition so that you can remember and do not lose any mark. So a large or a big molecule which is made by many small molecules, we call that as polymer. So large structure or a large molecule, that's one mark. Formed by small molecules joined together, that's the second mark. Proteins are natural polymers and proteins are biodegradable. Biodegradable means they can decompose by themselves, like hydrolysis of a protein. So protein is biodegradable, means decomposed by itself into amino acids. Now the question is, proteins are natural polymers, proteins are biodegradable. Name the type of linkage in protein. What kind of linkage is there in protein? So they have amide or peptide linkage. So you can mention amide, both are acceptable. You can say amide or you can say peptide linkage. What is meant by the term biodegradable? So definition of biodegradable means, you can see here, the polymer can be broke down by bacteria or smaller molecule. That's called biodegradable. Like there are certain now polymers are there, are even some artificial polymers are also biodegradable. So what happened, due to the bacteria, the polymer can break down into smaller molecule, so it does not produce or contribute to landfill. Otherwise, like example, plastic bags, shoppers which we are using normally, now they are replacing most of them by biodegradable, but before it was non-biodegradable, means the polymer cannot decompose by themselves. So that contribute to a landfill, pollution and garbage as well. If we burn these polymer, it produces a toxic gases. So there is no burning, it will reduce the landfill, but what happened? Like the site for the landfill, but it will release toxic gases. Biodegradable shoppers, biodegradable polymers are more efficient. Why? Because it can decompose. So it does not contribute to the garbage, the landfill, well, we don't have to burn them. So the term biodegradable means the polymer, the substance can decompose by microbes or bacteria. Name another natural polymer. What is another natural polymer? Carbohydrate, fat, protein. But another, if they say another, it means protein is not acceptable answer. Why? Because already they mentioned protein is a natural polymer. Proteins are natural polymers. So protein will not give you marks. It should be other than protein, which can be carbohydrate or fat. So in this one, nylon and tyrrolene are synthetic polymer. The repeat unit for nylon can be, this is the structure of a nylon they show, okay? The tyrrolene can be made from a monomer as shown. These monomers are given. This box is representing a carbon chain. So draw a diagram to show a repeat unit of tyrrhelline. What about, the question is, what about vitamins? Actually, vitamins cannot be synthesized. This group cannot be synthesized. You can take in your diet, your body cannot generate, so it cannot be synthesized by the body. So how we'll draw a polymer? We have to draw a polymer, tyrrhelline or polyester. So what we'll do, as you can see, if I remove H from one side, I will remove OH from another side. I remove H from one side and I will remove OH from another side. So what is left is the resultant polymer. So there will be O, then there should be a box. Then OH and H is being removed. So this oxygen will be there. So this oxygen, C double bonded with O. This box is there. And this is one molecule. Then repetition will be there. Then repeat with the same. This is what happened. Then there will be another. O will be there. Then box will be there for O, C double bonded with O. And there is a box. And then I will put N. What it means? It means that it continue. And this is called tyrrhelline or polyester. You can also say polyester. Why? Because it contains ester linkage and it's a polymer. Is it clear? And you can see the weightage of this organic chemistry. In this question, it was having 9 marks. Okay. And the previous discussion, we discussed one more question from the same paper of organic chemistry topic. This one, question 3, we discussed 13 marks. So means total 21 marks from organic chemistry out of 80. 80 the total marks for this paper, 80 and 21 marks, so about 25% of paper based on organic chemistry. So it's a very important topic, and even these 3 chapters are the 3 main topics: alkane, alkene, alcohol, carboxylic acid, and polymerization are covering this 21 marks. So try to focus on this organic chemistry as much as you can, which increase the chance of getting high grades. So October, November 2017. Study all the topics, but give more time to organic chemistry and practice organic chemistry every day so that you have a better understanding of the topic. Question number 4. Ethanol, which is C2H5OH, can be made by fermentation. Complete the chemical equation for formation of ethanol by fermentation. So glucose decompose into ethanol plus carbon dioxide. So we have to balance this equation. So if I put 2 here, carbon is balanced, oxygen is balanced, and hydrogen is also balanced. This is the equation. State 2 conditions for fermentation. What we need for fermentation? What are the conditions for fermentation? So we use yeast, which is having enzymes acting as a catalyst, about 30 degrees centigrade. In the anaerobic respiration, so in the absence of oxygen.
Yeast.
Yeah, so you can see the condition, the answers which are written here. Any two you can write from this 4. 37 or 30 degrees acceptable, because anaerobic condition, glucose in aqueous and yeast should be there. Any two you
Can
will.
you tell me? Can you
Yes.
tell me the definition of fermentation?
Fermentation is it's a process of forming alcohol by the help of glucose. That's called fermentation. And the condition to carry out fermentation is in absence of oxygen, in the presence of yeast, which is having enzymes, catalyze the reaction. The process of forming alcohol, ethanol by glucose is called fermentation. Ethanol can be made by catalytical hydration. The term hydration means addition of water. The equation is given or equation is shown for this hydration. Name a suitable catalyst for this reaction. What is the catalyst for hydration? What is the catalyst used for hydration? There is a catalyst. No, not nickel is for nickel is used for hydrogenation, means addition of hydrogen. Hydration. This is addition of water. Not propanoic acid, it is phosphoric acid is there. Concentrated phosphoric acid. So phosphoric acid is a catalyst for this reaction. Concentrated phosphoric acid. Ethanol can be oxidized to form ethanoic acid. So oxidation of alcohol result in a formation of carboxylic acid. What is a suitable oxidizing agent? Oxidizing agent for this reaction. Acidified potassium manganate 7. Better mention the term 7 as well. Acidified potassium manganate 7 for this reaction to occur. It is, you should write in Roman instead of writing in numeral. Write the number in Roman, because the charges or oxidation number in chemistry, when we represent in Roman numbers. So don't write like 7 or 2, just write Roman representation for that 7. Then we just have to complete a dot and cross diagram. So dot and cross diagram, CH, so carbon will share one with each hydrogen, share one with another carbon, and between there's a double bond. and here oxygen with carbon, and then hydrogen with oxygen. And unshared electron also we have to draw. So for oxygen, there will be how many unshared electron? It belongs to group 6, so it will share 2 and 4 of them are unshared. So what is the distribution of the mark? As you check, the distribution of the marks, mentioning all the shared electron, that's 1 mark. Mentioning a shared pair between carbon and oxygen, that's second. And total 8 electron in each oxygen means the unshared non-bonding electron for oxygen, that is a 1 mark as well. So total it will be 3 marks. The carboxylic acid react with alcohol to form ester. We call esterification. You can see this is a structure of an ester. The part of ester in the structure of ester, the part which is single bonded with oxygen, that part is called a branch, and the other C double bonded O part is known as the chain. Draw the structure of carboxylic acid and alcohol from which this ester is made. First thing, what is the name of this ester? Can you name this ester? What is the name of this ester? The part which is connected with oxygen is a branch, and the part which is connected with C double bonded with O is the chain. So first we name the branch and then we name the chain. What is the name of this ester? 4 carbon in the branch. So what we will call? 4 carbon in the branch. 1, 2, 3, 4. So it will be butyl. So 4 carbon in the branch, so we'll call butyl. And 3 carbon in the chain. So what we'll call? Prop. And they have a single bond in. And due to this functional group OH, so it is butyl propanoid. And as you know, the first name of ester is always coming from alcohol.
Sir,
Yes.
we will not write the position of the branch.
No, because in case of ester, the position of a branch is not important. It's only that a branch is there. It is obvious it is connected with oxygen for ester. That we discuss how to name the ester. So in case of ester, we don't mention like 1, 2, 3, which position. It is obvious that it is directly attached with oxygen. And the part which is coming from acid is the second name. So which alcohol and which acid react to form this? So actually it is butanol and propanoic acid. Butanol and propanoic acid. Why? Because 4 carbon, so we have to draw structure of acid and alcohol which result in a formation of this ester. So we have to draw carboxylic acid. As we know, this is butyl propanoid. So which carboxylic acid is there? Propanoic acid will be there. So drawing the structure of propanoic acid, prop means 3 carbon. So first I will draw 3 carbon. And C double bond, because it's a carboxylic acid, so functional group C double bonded with O and OH. And then put 2 hydrogen because 4 bonds should be there, and 3 hydrogen. And what is the name of this acid? The name of this acid is propanoic acid. Then we have to draw the structure of alcohol. So which alcohol? Because it's butyl, so it will be butanol. But means 4 carbon, so I should draw 4 carbon atoms. And OH is with the first carbon. And then put hydrogen. This will have 2 because 4 bonds are there. This will also have 2, 2, and 3. And name of alcohol, which alcohol? It is butanol. Is it clear? This was the structure of alcohol which react to form the following ester. 19 marks for this full part. If they did not mention, as you see, draw the structure, give the name. So they did not say show all the bonds. So I can draw like this, like because it was propanoic acid. So I can draw CH3, CH2, COOH. That is also correct. Because in the question it's not mentioned that show all the bonds. So if it is not there, show all the bonds, you can use any of the structure. This one is October, November 2018. Ethane is C2 and H6 is a member of homologous series alkane, and ethanol is C2H5 is also a member of homologous series alcohol. Alkanes are hydrocarbon. What is meant by the term hydrocarbon? What's the meaning of hydrocarbon? Contain carbon and hydrogen, and 1 mark is for mentioning only. That's a very important term when you define this. Hydrocarbon. All members of homologous series can be represented by a journal formula. State the journal formula for alkane. What is the journal formula for alkanes? It's CnH2n plus 2. And what is the journal formula for alcohols? No, journal formula for CnH2n, but alcohols. It's not alkene, alcohol. The journal formula for alcohol is CnH2n plus 1 OH. That is, you can write this CnH2n plus 1 OH, or you can write CnH2n plus 2 O. Both are the right ways. CnH2n plus 1 OH. Give 2 characteristic other than a same general formula for members of a homologous series. I already discussed this part in the previous paper. So it's just say, I will just show you the marking scheme so you can identify like what you can write. You can write they have similar chemical properties, same functional group, physical properties gradually changes, each member differ by CH2. Ethane can react with chlorine and it's a substitution reaction. What is the essential condition for this reaction? What is essential condition? So we need ultraviolet light or UV. It's in the presence of UV or ultraviolet light, this can happen. UV and high temperature, but the essential is ultraviolet light is essential, means even at temperature is high, but without UV, this will not occur. Draw the structure of organic product formed by substitution of one hydrogen atom in ethane with chlorine. So if one hydrogen is replaced by chlorine, so in place of hydrogen, I will draw. And here you can see, show all the atoms and all the bonds. So I cannot draw a structure. I cannot write like C2H5Cl. That will be not considered as correct. So I should show all the bonds. Name the product of a substitution reaction between ethane and chlorine that does not contain carbon. What else is there? Name the product of substitution reaction between that does not have any carbon. That's HCl or hydrogen chloride. So it's named, so you will not write a formula, you will name it. Hydrogen chloride. In part C, propanol is an alcohol, and propanol react with ethanoic acid to form ester. Name the ester which is formed. What will be the name of ester which is formed by reaction of propane 1-ol or propanol plus ethanoic acid? The first name of ester is from alcohol and the second name is from acid. So which ester is formed? It will be propyl ethanoate. Propyl ethanoate. Then draw the structure of the ester Y has a structure as shown. So they give you the name structure of this ester. Give a molecular formula of ester Y. Molecular formula, just count the number of carbon, like how many carbon atoms are there? 1, 2, 3, 4, 5. So C5. How many hydrogen atoms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C5H10 and O2. That's a molecular formula. Then draw the structure of carboxylic acid and alcohol which used to make this ester. So what is the name of this ester? You can see C double bonded with O and O. So this part is from alcohol and this is from acid. So which alcohol will be this? With OH is connected to a second carbon. So it will be butane 2-ol. And this is methanoic acid. How ester Y is formed? Because the name of this ester is butyl methanoate. So butyl methanoate, and the second carbon is attached with oxygen, so it will be butane 2-ol. So butane 2-ol and methanoic acid will result in a formation of this